What if I told you that everything you see, everything you touch, everything you are, makes up only 5% of what's actually out there? We live our lives on a brilliantly lit stage, blissfully unaware that the grand theater of reality is almost entirely dark. We are actors who know our lines, but we have no idea who built the stage, why the play is being performed, or what exists in the vast, silent audience of the cosmos. This isn't a work of fiction. This is the profound and humbling truth of our existence. We find ourselves adrift in an ocean of cosmic mystery. Our science, for all its power and precision, has led us to the shores of an even greater unknown. We've managed to read a single, illuminated page in a cosmic library filled with infinite, unread books, and on that page, we find the story of us. But what about the other books? What secrets do they hold? Today, we are going to journey into that darkness together. We will step off the edge of the familiar and wander through the great questions that haunt the heart of science. This is a journey that will take us from the very first spark of creation to the inner universe of our own minds. We will explore the hidden 95% of reality, confront paradoxes that defy logic, and stand in awe of a universe that is far stranger and more wonderful than we can possibly imagine. Every story has a beginning, but the story of our universe is missing its first page. Our best scientific theory, the Big Bang, tells us that about 13.8 billion years ago, everything, all matter, all energy, all of space itself, was compressed into a point of unimaginable heat and density called a singularity. From this single point, the universe erupted, expanding and cooling into the vast cosmos we see today. We can trace this history with astonishing accuracy, from the formation of the first atoms to the birth of stars and galaxies. It's like arriving at the scene of a cosmic explosion and being able to reconstruct the entire event from the shrapnel and the afterglow. But there's a profound problem. Science cannot explain the singularity itself. It cannot tell us what sparked that primordial fireball. What came before the Big Bang? The laws of physics, as we know them, break down at that point, leaving us with a cosmic question mark. It's the ultimate chicken and egg problem. To have a universe, you need a Big Bang. But to have a Big Bang, you need something to, well, bang. The beginning of everything, the moment of creation, remains a profound mystery. And as we began to map this expanding universe, we stumbled upon an even more startling realization. The galaxies, the stars, the planets, the nebulae, all the things we can see, are just the foam on the surface of a much deeper, invisible ocean. For decades, astronomers were puzzled by a simple observation. Galaxies are spinning too fast. Much too fast. Imagine a carousel spinning at high speed. The horses on the outer edge would need to be bolted down incredibly tightly to avoid being flung off. In the same way, the stars on the outer edges of galaxies are moving at such incredible velocities that the gravitational pull of the visible matter alone is not nearly enough to hold them in orbit. They should be flying off into the void. The fact that they aren't tells us there's something else there. A huge amount of unseen mass providing the extra gravitational glue. Scientists call this invisible substance dark matter. It's called dark, not because it's sinister, but simply because it doesn't seem to interact with light or any other form of electromagnetic radiation. It doesn't shine, it doesn't reflect, it doesn't cast a shadow. It's a ghostly scaffolding upon which galaxies are built. making up about 27% of the universe. It's passing through your body, through the earth, through everything, right now, and we don't feel a thing. We know it's there, but we have no idea what it is, as if one cosmic ghost wasn't enough. In the late 1990s, astronomers made a discovery that shook the foundations of cosmology. They were trying to measure how much the expansion of the universe was slowing down due to gravity. Instead, they found the exact opposite. The expansion is speeding up. Think about that for a moment. It's like throwing a ball into the air, and instead of slowing down and falling back, it suddenly shoots upwards, faster and faster, into the sky. Some unknown force is actively pushing the universe apart, counteracting gravity on the largest scales. This mysterious force is called dark energy. It's even more prevalent than dark matter, making up a staggering 68% of the cosmos. And just like dark matter, we have no idea what it is. It seems to be a property of space itself. The more space you have, the more of this anti-gravity effect you get. So let's do the math. About 68% of the universe is dark energy. About 27% is dark matter. That leaves us with a humbling conclusion. Everything we have ever seen, from the most distant quasar to the screen you're looking at right now, makes up less than 5% of reality. We are just beginning to glimpse the true nature of the cosmos, and it's telling us that most of reality remains utterly hidden from us. As we delve deeper into the nature of our universe, the mysteries only multiply. It's not just the stuff in the cosmos that's strange. It's the rules themselves. The universe operates on a set of fundamental physical laws and constants that seem to have been balanced on a knife's edge, uncannily fine-tuned to permit the existence of life. Consider the force of gravity. If it were just a tiny bit stronger, the universe would have collapsed back in on itself moments after the Big Bang. If it were a fraction weaker, galaxies and stars would never have been able to form. Or take the charge of an electron, alter it ever so slightly, and chemistry as we know it would be impossible. The same goes for the strength of the nuclear forces that bind atoms together. Had any of these fundamental values been different, the cosmos would be a barren, lifeless place, filled with nothing but a thin soup of hydrogen gas, or crushed into a sea of black holes. It's like walking into a room and finding an incredibly complex safe with billions of dials, and discovering that they are all set to the precise combination needed to unlock the door. This extraordinary balancing act is known as the fine-tuning problem. Why are the laws of physics so perfectly calibrated for life? Is it an extraordinary coincidence? Is it a sign that our universe is just one of many in a vast multiverse, and we simply happen to exist in the one where the conditions were right? Or does it point to a deeper principle of nature we have yet to discover? Equally mysterious is the very fabric of our experience. Time. At the most fundamental level, the laws of physics don't care about the direction of time. Equations like Newton's laws of motion or Einstein's theory of relativity work just as well forwards as they do backwards. A video of planets orbiting a star would look just as physically plausible if you played it in reverse. Yet, in our everyday lives, time has a very clear and undeniable direction. We remember the past, but not the future. A glass can shatter into 1,000 pieces, but we will never see those pieces spontaneously leap back together to form a glass. This one-way flow is often called the arrow of time, and its origin is one of the deepest puzzles in science. The leading explanation is tied to a concept called entropy, which is essentially a measure of disorder or randomness in a system. The second law of thermodynamics states that the total entropy of an isolated system can only increase over time. The universe began in a state of incredibly low entropy, a highly ordered state, at the Big Bang. Since then, it has been moving towards a state of greater disorder. The shattered glass represents a much more disordered and thus more probable state than the perfectly formed glass. But this physical explanation doesn't fully capture our subjective experience of time's passage. Why do we feel ourselves being carried along by its current? Our perception of time is intimately linked to memory and consciousness. We are creatures who build a story of ourselves based on a sequence of events, a remembered past, a perceived present, and an anticipated future. This one-way street of our lives, the most familiar aspect of our reality, suggests that our very existence is tied to a cosmic principle that science still doesn't completely understand. When we leave the world of the large and predictable and peer into the realm of the very small, reality itself begins to dissolve into a realm of strange and uncertain possibilities. This is the world of quantum mechanics, and it is a world that defies our everyday intuition. Here, a particle like an electron doesn't have a definite location until you measure it. Instead, it exists in a ghostly state of all possible locations at once, a superposition of possibilities described by a wave of probability. It's not just that we don't know where it is. In a very real sense, it isn't in any single place. It is a cloud of potential. The act of observation, of measurement, seems to force this cloud to collapse into a single, definite reality. This raises a profound philosophical question. What constitutes an observation? Does it require a conscious observer? Why does the universe seem to change its nature just because we looked at it? This is known as the measurement problem, and it suggests that the relationship between reality and the observer is far more intimate and mysterious than we ever imagined. Stranger still is a phenomenon that Albert Einstein famously called spooky action at a distance. This is quantum entanglement. It's possible to link two particles in such a way that they become, in a sense, a single entity, no matter how far apart they are. Their properties, like their spin, become perfectly correlated. If you measure the spin of one particle and find it to be up, you will instantly know with absolute certainty that its entangled twin, even if it's on the other side of the galaxy, will have a spin of down. It's as if you have two magic coins. You give one to a friend who travels to a distant star. The moment you flip your coin and see that it's heads, you know that their coin has instantly turned to tails. This communication appears to happen faster than the speed of light, which, according to Einstein's theory of relativity, should be impossible. While entanglement can't be used to send information faster than light, it reveals a hidden layer of connection in the universe, a profound interconnectedness that defies our conventional understanding of space and time. It challenges the very idea that two objects can be truly separate, suggesting that at the deepest level of reality, the universe is a unified, indivisible whole. As we turn our gaze back to the vast cosmic ocean, we find it's filled with objects and events that defy our neat explanations. Our universe is not just a quiet, orderly place. It's a dynamic and violent arena, home to celestial enigmas that challenge our models of how things ought to work. At the heart of nearly every large galaxy, including our own Milky Way, lurks a monster, a supermassive black hole, weighing millions or even billions of times more than our Sun. The puzzle is that we see these giants fully formed very early in the universe's history. Our theories suggest that black holes grow by swallowing gas, dust, and stars, like a snowball rolling downhill. But the black holes we see in the infant universe are like finding a giant boulder at the top of the hill just moments after the first snowflake fell. They grew far too big, far too quickly, and we don't have a complete explanation for how. The galaxies themselves hold their own secrets. Why do so many of them, like our own, spin their stars into elegant, stable, spiral arms? The prevailing theory involves density waves, slow-moving traffic jams of stars and gas, but it does not fully account for the longevity and perfection of these majestic structures. From the distant cosmos, our radio telescopes are picking up mysterious signals known as fast radio bursts, FRBs. These are incredibly powerful flashes of energy, some releasing more energy in 1,000th of a second than our sun does in a day. And then they're gone. We don't know what creates them. The leading candidates are highly magnetized neutron stars called magnetars. But the sheer power and variety of FRBs have left scientists baffled. They are whispers from the void, and we have not yet learned their language. And we don't need to look billions of light years away to find profound mysteries. Our own solar system is a collection of cosmic oddballs. Uranus, for instance, doesn't spin like the other planets. It's been knocked over on its side and rolls through space like a barrel. What colossal impact in its distant past could have caused such a dramatic tilt? Venus, often called Earth's twin, rotates backwards and so slowly that its day is longer than its year. Its thick, toxic atmosphere has created a runaway greenhouse effect, a stark reminder of how planetary climates can go terribly wrong. And then there is Saturn. Its magnificent rings, a jewel of the solar system, appear to be far younger than the planet itself. Data from NASA's Cassini mission suggests they may only be a few 100 million years old, a mere blink of an eye in cosmic time. This means they are likely a temporary feature. What created them? A moon that was shattered by Saturn's gravity? A captured comet torn to pieces? Our own celestial backyard is a constant reminder that even the things we can see up close are filled with puzzles yet to be solved. Over 3.5 billion years ago, on the rocky, sterile surface of a young Earth, something extraordinary happened. Non-living chemistry, a simple soup of organic molecules, crossed an invisible threshold and awoke into life. How this transition, known as abiogenesis, occurred is one of the greatest unanswered questions in all of science. We don't know if the spark of life ignited in warm sunlit pools on land, as Charles Darwin speculated, or in the dark, energy-rich hydrothermal vents deep on the ocean floor, protected from the harsh radiation bombarding the early planet. We also don't know why a specific molecule, DNA, with its iconic double helix structure, became the universal standard for storing biological information. Every living thing on this planet, from the smallest bacterium to the largest blue whale, uses the same genetic code. This points to a single origin, a last universal common ancestor from which all life on Earth is descended. But were there other, competing forms of life that lost the evolutionary race? This single origin on Earth leads to perhaps the most profound question of all. Are we alone? Our galaxy contains hundreds of billions of stars, and we now know that planets are incredibly common. There could be tens of billions of Earth-like planets in the Milky Way alone. Add to that the possibility of life in hidden oceans beneath the icy shells of moons in our own solar system, like Jupiter's Europa or Saturn's Enceladus. The potential habitats for life seem to be abundant, and yet the cosmos remains silent. For decades, we have been listening for signals from other intelligent civilizations, but have heard nothing. This deafening silence is known as the Fermi paradox. If the universe is teeming with life, where is everybody? Are we the first intelligent species to arise? Do civilizations inevitably destroy themselves before they can reach for the stars? Or is the universe a far more lonely place than we'd like to believe? The silence itself is a piece of data, and its meaning is one of the most haunting enigmas we face. Perhaps the most intimate and most perplexing mystery is not out in the depths of space, but right behind your eyes. It is the mystery of consciousness. Science can describe the brain in exquisite detail. The intricate network of 86 billion neurons, the electrical impulses and chemical signals that allow us to process information, learn, and react. But it cannot yet explain how this 3-pound lump of tissue produces the subjective inner experience of being alive. This is what philosopher David Chalmers called the hard problem of consciousness. The easy problems involve explaining the functions of the brain. The hard problem is explaining why we have an experience at all. Why do you have the feeling of redness when you see a rose? Why does music evoke emotion? Why is there something it is like to be you? We are, each of us, a universe of thoughts, feelings, and sensations. And science has no explanation for how this inner world arises from physical matter. Every night, we slip into another mysterious state of consciousness, the world of dreams. What is their purpose? Are they simply the brain's way of consolidating memories, filing away the important events of the day? Or are they a form of emotional regulation, a safe space to process feelings and anxieties? Some theories even suggest that dreams are a kind of threat simulation, an ancient defense mechanism allowing us to practice for dangerous situations. The surreal, often illogical nature of dreams remains a puzzle, a nightly journey into a part of ourselves that we barely understand. Our perception of time is equally puzzling. It is not the steady, ticking clock of physics. It is an elastic, subjective experience. Time can feel stretched during moments of intense fear, as the brain frantically processes information, or compressed during moments of joy. Why does time seem to speed up as we get older? Is it because, as adults, our lives become more routine, and we form fewer new, distinct memories, causing the years to blend together? The very memories that constitute our identity, our sense of self, are stored and recalled through mechanisms we are only just beginning to grasp. The ghost in the machine, the conscious self, remains the most profound unknown. As we look beyond ourselves to the animal kingdom, we find it filled with abilities that seem almost magical, instincts that defy simple explanation. These creatures reveal that our human experience is just one version of reality, and that the world is rich with senses and abilities we can only envy. Every year, millions of monarch butterflies migrate thousands of miles from Canada to Mexico, a journey to a place none of them has ever been before. Arctic terns fly from the North Pole to the South Pole and back again, an annual round trip of nearly 50,000 miles, the longest migration on Earth. How do they navigate with such impossible precision? They use a combination of cues: the sun, the stars, and even the Earth's magnetic field. But how this internal map and compass is encoded in their genetics and passed down through generations remains a deep mystery. It is an inherited global positioning system that science cannot yet read. Some animals have mastered life and death in ways that seem to defy biology. The salamander can regenerate entire limbs, parts of its heart, and even sections of its brain perfectly and without scarring. If we could unlock the genetic secrets behind this remarkable ability, it could revolutionize human medicine. The Greenland shark, living in the cold, dark waters of the North Atlantic, can live for over 400 years. Its cells holding secrets to longevity that elude us. These creatures sense the world in ways we cannot. Birds use magnetic fields to guide their journeys. Homing pigeons can find their way home from hundreds of miles away, even when their known senses are blocked, suggesting they are sensitive to forces we don't yet understand. Bees see the world in ultraviolet light, perceiving patterns on flowers that are invisible to us. Bats and dolphins build a picture of their surroundings with sound. Their reality is fundamentally different from ours. They are a quiet reminder that our human senses perceive only a narrow sliver of the full spectrum of what is real. In the end, our journey into the great unknown brings us full circle, back to ourselves. As a species, we are defined by behaviors whose origins remain profoundly mysterious. Even as we seek to understand the cosmos, we are still an enigma to ourselves. At some unknown point in our past, we developed language. It is the tool we use to build civilizations, share complex ideas, and convey our innermost thoughts. But we don't know how it began. Was it a gradual evolution from simple grunts and gestures? Or was it a sudden, revolutionary leap, perhaps caused by a single genetic mutation that rewired the human brain? There is no fossil record of the first word ever spoken, so its origin remains one of the most significant and elusive questions in human evolution. Our lives are filled with universal human experiences that have no clear evolutionary purpose. Laughter, music, art, and storytelling are found in every human culture across the globe, yet they don't directly help us find food or avoid predators. What is the advantage of a good joke or a beautiful melody? Perhaps their purpose is not survival of the individual, but the strengthening of the group. These shared experiences build social bonds, create community, and allow us to share emotions and ideas, the very fabric of our societies. And finally, there is our most defining trait, an insatiable, relentless curiosity. We are driven by a need to explore, to understand, to know. It's the force that pushes us to climb the highest mountains, dive to the bottom of the ocean, and build giant telescopes to peer at the edge of time. This drive has no obvious, immediate survival benefit. It is a deep, intrinsic part of what it means to be human, and its source is as mysterious as the cosmos it compels us to explore. We have journeyed from the edge of creation to the heart of the human mind, and everywhere we have looked, we have found mystery. The universe, it seems, is not a problem to be solved, but a story that is still unfolding. The greatest lesson these enigmas teach us is humility. They remind us that our knowledge is a small island in a vast ocean of the unknown. But this shouldn't be a source of fear. It should be an invitation. Mystery is not a void. It is a space for wonder, for imagination, and for the relentless curiosity that defines us. In our daily lives, we can apply this lesson by approaching the world with a little less certainty and a lot more curiosity. Be open to the idea that you might be wrong. Listen to perspectives that challenge your own. Understand that not having all the answers is not a failure, but an opportunity to learn. The joy is not just in finding the solution, but in the thrill of the search itself. So, I leave you with a few questions to ponder. Of all these mysteries, which one fascinates you the most and why? Do you believe we are alone in the universe? Or is the great silence hiding something we can't yet perceive? And what do you think consciousness truly is? I would love to read your thoughts in the comments below. Thank you for joining me on this journey into the great unknowing. I hope it has sparked your curiosity and filled you with a sense of wonder for the incredible, mysterious universe we are all a part of. Take care of yourselves, stay curious, and if you enjoyed this exploration, please don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next adventure into the unknown.